Good morning, everyone. Welcome to Software Engineering. I'm Zhang Shuang from Software College, Northeastern University. The topic of this lecture is coupling. In the previous lecture, we have learned coherent. Coherent is the interaction within a module. Coupling is the interaction between modules. There are three paths for different level of coherence between modules. So you see, each part is a module, and in this part, there's no coupling between modules. Well, the second, there are some coupling with some interaction between modules. Well, the third one, there are quite a lot of interaction between modules. So the first one is called no coupling, and the second one, loosely coupling, and the third one, tightly coupling. Which one do you think is the best design for a software system? So this is what we are going to learn in this lecture. After we studied about coupling, we can answer this question. Okay. There are 5 categories or levels of coupling. The first, content coupling, and the second, common coupling. The third, control coupling. The fourth, stamp coupling, and the fifth, data coupling. And actually, level 1, content coupling, is the worst, okay? And the data coupling is the best, okay? So you can see that from the worst to the best coupling. Okay, let's learn it one by one. First, content coupling. 2 modules are content coupled if one directly references content of the other. For example, here is Java code, class product, and it has an attribute unit price. Well, in another class order, within a method, this class order is trying to assign the value for the attribute object of class product. You see, my product is just an instance of the class product. So you can see that this class or this module order just access the data, and the data is also part of the content of another module product, right? Okay, so this is content coupling. How is it? Do you think it's good or bad? So next level, common coupling. 2 modules are common coupled if they have write access to global data. For example, module CCA and the module CCB, they can access and change the value of some global variables. Well, this is quite common in structured programming with the use of global variables. All of us has the experience of structured programming, and sometimes we need some common data, some global data that can be accessed from different modules, from different functions. So normally, the solution will be the global variables. What do you think about it? For example, you get module A, B, and C, and the 3 modules will need some common data. So the programs will be something like this. Maybe you think it is quite convenient. It works. Well, let's take another example. Now we get 6 modules, A, B, C, D, E, F. And all of them have some common data. Well, the common data will be accessed or modified by different modules. How is it? And then the program will be like this. Will you say it's convenient? Well, it is quite confusing. It makes things complex now, right? And maybe you can say that it is just a mess. So you can see that sometimes the use of global variable just makes the programs virtually unreadable. Let's take this code for example. Sometimes the code will be like this. Some global variable satisfy some condition, and then something happen, and so on, right? So you can see that the global variable is taken as switch in some module, and it is modified in some other modules. So this will affect their readability. It is really very hard to understand it. Just imagine this example. And the entire module must be read to find out what it does. And surely it is difficult to reuse. And the module exposed to more than necessary. In the level first coupling, content coupling, one module can access the content of another module. That means it can control it, it can modify it. It is the worst. Okay? It is very dangerous, right? That means some module cannot be independent, right? Well, at this second level, common coupling, things are still not so good. It's still so bad. Because the modules will share some common data, and sometimes the common data will be out of control because it can be accessed by any module. Level 3, control coupling. Two modules are control coupled if one passes an element of control to the other. For example, if control switch passed as argument. For example, module A call module B, and the module B will calculate average score or highest score. So what does module A want? Actually, module A will pass a switch to module B, average or highest. So surely if a switch of average is passed to module B, and then module B will calculate the average score for module A and return the score to A. Okay. And if the highest is passed to B, module B will determine the highest score and take it as the result back to A. Now we can see that module A is controlling the flow of module B. And what kind of coherence will module B have in this way? Yes, logical coherence, right? And we have understand that the logical coherence is not good. It should be avoided. Okay. So control coupling is also not good. It should also be avoided. So the solution is split module B into two modules, B1 and B2. And the B1 is for calculating average, and the B2 is to calculate the highest, right? And the feedback will be just the average or highest separately. So why is control coupling so bad? Because modules are not independent. Module B, the code module must know internal structure and the logic of module A. So that affects reusability. And just like what we have discussed just now, that control coupling is associated with modules of logical coherence. Both should be avoided. Level 4, stamp coupling. Some languages allow only simple variables as parameters, such as path number, satellite altitude, degree of multiprogramming, and so on. Well, many advanced languages support parsing of data structure, such as a record, or coordinates, or a table, and so on. Two modules are stamp coupled if a data structure is passed as a parameter, but the called module operates on some, not all of the individual components of the data structure. So, in one word, more than enough data is passed as parameter. So here's an example. Class order and the method get the total cost. The parameter is structure of customer. Customer is another class. And an instance of customer is passed as a parameter. Well, inside the method, the instance level and the bonus point is get. So the customer level and the customer bonus point is used for the following calculation. So actually you can see that only two data is needed from the data structure, and the other part of the data structure won't be used. So you can see that more than enough data is passed as a parameter, and this is called stamp coupling. Well, is it good or not? Well, we must admit that it is not clear without reading the entire module which fields of a record are accessed or changed. So that means it is difficult to understand the module, the interface, and it is unlikely to be reused. So more data than necessary is passed, and uncontrolled data access can lead to computer crime, right? Well, surely there's nothing wrong with passing a data structure as a parameter, provided all the components of data structure are accessed and all changed. For example, invert matrix, and it has two parameters. One is the original matrix, and another is the inverted matrix. And one more case, print inventory record, and the parameter is warehouse record. It's okay because all the data inside the data structure will be used. Well, level 5, data coupling. Two modules are data coupled if all parameters are homogeneous data items, that means simple parameters, all data structures, all of which elements are used by called module. For example, display time of arrival, and the parameter is flight number, and the compute the product, the parameter is first number and second number, and the get job with highest priority, and the parameter is job queue. So data coupling is the best. Why? Because the difficulties of content, common, control, and the stamp coupling are not present. And of course, the maintenance will be easier. Okay. So far, we have learned coherence and coupling. Coherence is the degree of interaction within a module, and coherence is the highest, the best. Well, the coupling is the degree of interaction between modules. Well, the lowest coupling, the best. So the rules for good design is to try to achieve high coherence and low coupling. Okay, so much for this lecture. Thank you.